of a Turing machine for a given language, similar to push down automata. Here also, for any given language, how to construct its Turing machine. So here also, we don't have any theorem or algorithm to define a standard procedure for the given language based on the nature of the language or what type of strings it derives. Based on that, the procedure is changed language to language. So here, the basic guidelines for designing a Turing machine for a given language is based on the following two steps. So here first, what you have to do for any given language, whenever you are designing a Turing machine, so the finite control scans a symbol by using read or write header and is to know what to do in the future. After scanning an input symbol, so what is the future? What it has to be done in future? That means the machine must remember the past symbol scanned. So every time scanning the input, then what will happen? Then it remembers previously scanned symbol also. That is step one. Then step two, change the state. The finite control changes the state only when there is a change in the movement of read or write header. Suppose after reading an input symbol, the read or write header may changes either towards left or right. So at that time, it changes the state. So these are all the general basic guidelines for designing a Turing machine for any given language. So now let us see one example problem. Here you will get clear idea. So the question will be given like this in examination. Obtain a Turing machine to accept the language or construct a Turing machine to accept the language. Suppose here the given language L equal to 0 power n, 1 power n such that n greater than or equal to 1. Similar example we discussed in PDA also, but that is different. Then Turing machine construction is different. So here, what is the nature of this language? We know the given language accepted by a Turing machine should have n number of zeros. Why? Because 0 power n followed by n number of ones. That means whatever the value of n for both zeros and ones, repeat that number of times based on the n value. So first zeros followed by ones. So for this, let us take an example of the string. For example, n is 3. If you can take n as 3, now you can see n as 3, then 0 power 3, 1 power 3. If you can expand this one, 3 zeros, 3 ones. So the string is 3 zeros or 3 ones. Or if you can take n as 4, whatever, no problem. The string w should be accepted as, here for example, here we have considered 4 zeros followed by 4 ones. So whatever you can take. So preferably you can take some medium long range string. Then don't take too much long, then too much short string. Medium range you can take. Then our design will be more effective. So now lively I will explain how to solve this problem. So here we don't have any systematic procedure here. Based on the strings of the language, the logic is designed. So here what you have to do for given language L equal to G, okay, let us take a power n, no problem, whatever the inputs, a power n, b power n, such that n greater than or equal to 1. So let n equal to 3, then a power 3, b power 3 equal to 3 a's, 3 b's. So here, what is the logic? So first, store the input on Turing tape, followed by blanks. Now this will becomes, now you can see here we have 3 a's, then 3 Bs. At the end, you can include blanks whenever if you want to extend the Turing tape towards right end infinitely based on the symbols. So this is the initial configuration, what you have to do. Finally, what you have to do, if you can see the nature of the string here. So first here 3 A's are there, then 3 B's are there. So what Turing machine will do, after scanning the first symbol from the leftmost cell of the tape, then it moves to the next cell by changing the state or without changing the state also. Then for our understanding purpose, so the Turing machine, just now we mentioned, it remembers the past scanned symbols. So how to identify the previous symbol is already scanned. That means after scanning a symbol, it may be replaced by with other symbol. So here the nature of the language is first number of A's followed by number of B's. Suppose here we have taken 3 A's, 3 B's. So here first A will be scanned. Then after one A is scanned, then what it has to do immediately, it won't scan the second A. It goes to right and it searches for the first B. Why? Because here A and B should be matched. Why? Because we have same count, 3 A's, 3 B's. That's why what it has to do, first it scans A, first scan A, then search for first B, then it scans first B. Then what you have to do, second time it scans, this is second scan A, then immediately it search for second scan of B. Then this is third scan A, then it search for third B, then third scan B. So here you can observe, here directly we are saying first it scans the first A, then it scans the second A. In the second part, first B. But directly it won't do like that. So here you can see the tape consisting of 3 A's, 3 B's followed by blank. So whenever first A is scanned, then it has to move towards right to search for first B. For that, what it has to do, here after scanning one A, we have another A also, third A also. All these A's are skipped without changing state. It skips until it finds the first B. Whenever first B is found, then what it has to do, it is replaced by some other symbols. Then what it has to do, it won't move right. Why? Because it goes left, then it scans for second A. Then after second A is replaced, then it goes right and search for second B. So where second B is there? Here. To come to second B, it has to skip all others. Like here A is skipped. Now earlier B is replaced with symbol, whatever the symbol, that is also skipped. Then whenever it sees the second B is replaced by C, whatever the replacement symbol you are using. For A's, you can use one uniform replacement symbol. Then for B's, you can use other uniform symbol. So then second B is replaced again. It has to move towards left, then search for third A. Whenever third A is replaced, then it goes right and it search for third B. Then whenever third B is also replaced, then again it's come back. It scans if any more A's are there or fourth A is there. So at that time, whenever it is coming back, all the replacement symbols are skipped. So then it searches. If next A is found that is replaced with the same symbol, whatever the replacement symbol we used, then it moves right, search for next B. Suppose here further no replacement symbols are there, then it skips all, then it says any B's are there. Then no B's also there, then it moves right whenever blank is found. Then it goes to other new state, then it halts at that state. Then finally, wherever it is halting, that state is called as accepting or final state. So that is the logic needs to be followed here. So here for replacement, let us assume, so let us replace A's by using uppercase letter X and B's by using uppercase letter Y. Okay, whatever the symbols, but uniformly all A's, wherever A is there, after scanning, whenever replacement is possible, it has to be replaced with X. Then whenever B is found, so whenever replacement is possible, B is replaced with Y. Now, initial configuration of the tape. So the initial configuration, what tape contains 3 A's and 3 B's. So then the final configuration, what it contains. So all A's are replaced with X, then all B's are replaced with Y. That means the final configuration. So here A is replaced with X, second A also X, third A is also X, then first B is Y, second B is also Y, then third B is also Y. So whenever the final configuration will be, here we can see equal. So 3 A's are replaced with same symbol. Then 3 B's also replaced with the same symbol Y. Here 3 A's replaced with X. So then right side blank is there, means the Turing machine halts at the accepting state by putting the equal number of A's and equal number of B's on the tape. That means matching 3 A's and 3 B's. So both count will be matched. That to order A's followed by B's, like that. So now to get this one, here what you have to do. So here directly I will take the string, then whatever the steps we are performing, then the corresponding transitions will be taken. So here 3A, 3B's is considered as our string. So here you can make in the form of tape diagrammatic representation or directly in the acceptance case also. So now what you have to do, now your control is at the input symbol A, then the current state is Q0. So whenever it reads the first input symbol, what it has to do, what we mentioned, the A is replaced with X. So A is replaced by X, then it moves right, then it changes the state. Now Q1. Now the remaining inputs are, now you can see when change of state is occurred, whenever an input is replaced with a particular X or Y, then only you can change the state. Suppose whenever you are skipping without replacing, just you are skipping, at the time don't change the state. So change of state occurs only whenever replacement occurs. So now here you can see here what is the transition we used, that you can write down. Delta of current state is Q0, current input is A, then Q0 is changed to Q1, then A is replaced with X, then it moves right direction. This is the first transition. Like that, step by step, you can write down whenever new transition is introduced. Now you can see the state is Q1 now. The current input is A. What we mentioned, after the first input is replaced with X, then the control moves right with help of read write header to find the first B. Where first B is there, here you can see, here you have to skip the second A, you have to skip the third A without changing state. Then it says the first B. Whenever first B is found, B is replaced with Y, then again it moves left to search for second A. Like that, this will be repeated. Now you are at Q1A. In Q1A, what you have to do, you can't replace anything, the second A. You have to replace only the first B. That's why you have to skip all A's and moves right until you will find the first B. Now Q1A, you have to skip simply without changing state. Now Q1A, A is replaced with A, same state, it moves right. Then the remaining symbols same. Now here, what is the transition we used? This is a new transition, delta of Q1 on input A. Here we are not changing the state. Same state, A is replaced with A, then it moves right. So that means this transition is used to skip A's. To skip S, this transition is used. Now again you can apply the same transition because again we have another A is there. Now X A. Now A is replaced with A, then it moves right. Now without changing the state. Now Q1, then the remaining inputs are B, B, B. Now you can see your finite control is at the cell, the first B, then the current state is Q1, Q1B. Now whenever first B is found, as per our logic, what we discussed, this B is replaced with Y, then moves left by changing the state. Why? Because here B is changing with a new symbol. So you have to change the state. Now X, A. Now B is replaced with Y, then it moves left towards one cell. So now here before A, now what is the new state here? Q2A. Now the remaining two B's are same. Here the new transition is there. What is the new transition here? Q1 on B equal to, we are changing the state Q1 to Q2. B is replaced with Y, then it moves left. Now we can see here first B is replaced with Y. Then what we have to do? We have to go back and search for second A. So whenever you are coming back, see, whenever you are coming back, you can see any A's are there. You can skip all A's. Why? Because immediately you can't replace the preceding A. So whenever you have to going back to the leftmost cell, after seeing the first replacement X, then it moves right. Then only whatever the A we will find, that is the second A. That can be replaced with X and moves right. Like that, the same process is repeated. Now you are at Q2. Input is A. You have to skip A without changing state. So now and moves left. Now here X, then again Q2 A, Y, BB. Here you can see it moves towards left to this cell. Now A is replaced with A. Again here one new transition we obtained, that is delta of Q2 on A equal to, without changing state, it is going to Q2, A is replaced with A, then it moves right. Why you are moving left? Why you are moving to left means to search for second A. But where you will get second A? After moving to the leftmost cell, first replacement, then moves right. Whenever it moves right, whatever the A you will get, that is the second A. Now again see, we are at Q2A, same we can apply. It moves left by replacing A by A. Now Q2A, so it moves left without changing state. Now Q2X, then A is replaced by A, remaining symbols as it is. Here Q2A, this transition already there, same we used. If any repeated transitions occurred, you no need to write. Whenever unique transitions are there, you can write down. Now you can say you are at Q2X. So Q2X means whenever X is found, simply X is replaced with X, then it goes to the initial state, Q0 state, then moves right. Now X is replaced with X, it goes to Q0 state, then it moves right. It moves right means it comes after X. Now the state is A. Why you are going to B? Why? Because initially the replacement happens at the Q0 state. So it goes to Q0 state itself. Now here, what is the new transition? Delta of Q2 on X equal to, now Q2 to Q0, it is going to Q0, X is replaced by X, it moves right. Now you can see you are at Q0 state and the input is A. This is the second input A. Now this transition we already used in the first step. So delta of Q0 A equal to Q1X R. So same we can apply. So now here repeated transitions you can include only once. Now Q0 A is replaced with X, then it is going to Q1 state, then it moves right. Now the remaining symbols as it is. Here whatever the transition we used, delta of Q0 on A equal to Q1 comma X comma R, that is already there. So here no need to take, that is not a new transition. Now you can see we are at Q1 state, the input is A. Then what we have to do, our second input A is replaced with X. Then what is our next goal? You have to search for second B. So whenever if you want to search for second B, so here before second B, you may get A's, you may get Y's. All you can skip without changing state till you will get the second B. Now at Q1 state A is there, so A is skipped, then moves right, then you will get Y. Y also skipped, moves right until to get the second B. Now see Q1A, is there any transition for skipping? Yeah, it is already there. So Q1A equal to Q1A R. So apply the same transition. Now skip here. Now here you will get x, x. Now A is replaced with A, then it moves right without changing state. Now you are at Q1, the current symbol is Y. Now you can see Q1, Y. So whenever you will see Y, also you can skip Y by Y. Why? Because after Y, whatever the B you will get, that is the second B. So you can skip Y also. But Q1, Y, see you don't have this transition. This is the new transition. Therefore, you can skip Y without changing state, then moves right. Now XXA, now it moves right without changing state, Y by Y. Now the state is same. Now BB. Here this is a new transition. Delta of Q1 on Y equal to without changing state. Q1, Y is replaced with Y, then it moves right. This is another new transition. Now you can see you are at Q1, the input is B. So this was already happened in the previous. First B is replaced. So delta of Q1 B equal to Q2, B is replaced with Y, then moves left. Why? Because whenever second B is replaced with Y, then it won't move right, it moves left until it sees the replacement symbol X, then it searches for third A. Like that, this process is repeated. Now Q1B, now the B is replaced with Y, it moves left. Now here A, so now it moves left means here the state is Q2 Y. Now this B is replaced with Y, the remaining B as it is. Here what is the transition? Q1B, this is already there. So you no need to take repeated transition. Now you can see you are at Y, the state is Q2, Q2Y. So whenever further until you will get X, you can skip all Y's, all A's and moves left. Now Q2Y, so this is a new transition. Q2Y skipping step we don't have, but Q1 we have, but you are at Q2 states. Therefore, now another new transition you can write down. First you can skip XX. Now Q2 is will be in the same state. Then A. Now Y is replaced with Y, moves left. Just skipping. Here the new transition is Q2 on Y without changing state. Q2 Y by Y, then moves left. Now you are at Q2 state. Now your input is A. So here also you can skip A. Why? Because to get X, you have to move left. See Q2A, this skip transition already there. So Q2A equal to Q2A L. Apply this step. So now you will get skipping A by A without changing state, it moves left over the X. Now you will get X, Q2 X, then A is replaced with A and moves left, then Y, Y, B. Here now you can see you are at Q2 state, the symbol is X. So Q2 X, we have already the transition. So Q2 X equal to, it is going to Q naught. X is replaced by X, moves right. So whenever X is found. So now apply the transition. Now X is replaced with X, then it moves right. Then it is changing state to Q naught. Then A, Y, Y, B. Now you can see whatever the A we got now, this is the third A. Now the state is Q naught. Again, you can apply the same step as in first step. So Q naught A means A is replaced with X and moves right until it scans the third B. Now Q naught A, this transition already we have. Now X is replaced with X, then Q naught A. The transition is A is replaced with X, then it moves right by changing state Q1. Now you will get at Q1 Y, Y, B. Now you can see, so except B, whatever the symbols we will find, all you can skip till you will get B. Now Q1 Y, already we have the transition. Without changing state, Y is replaced with Y and moves right. So till you will get the B. Now you can say Q1Y skip without changing state. Now Q1Y, Y is replaced with Y, moves right without changing state, Q1, Y. We have another Y also. Same transition I can apply Q1Y. Already this transition is there. If it is new, you can write down. Now again here you have to skip. Now X, 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 then Y. Now Q1 Y. So Y is replaced with Y, then it moves right. Now Q1B. Now you can see your input is B, the state is Q1. Now Q1B, that is the third B is found now. So for Q1B, we have the transition here. Q1B equal to Q2, B is replaced with Y, then moves left. So now here this B is replaced with Y, then it moves left. Then the configuration becomes, now it moves left means over this one by changing state. Here Y, then Q2 Y. Now this B is also replaced with Y. Now again, whenever it is coming back, so whenever any B's, any A's, any Y's, it skips all, then moves left till it sees X. Whenever X is found, that is replaced with X and going to Q0 state and moves right. After X, whenever it is moving right, if another A is found, then again that is replaced with X, then it moves right, skipping all till it gets another B, like that. Now we will see what will happen here. Now Q2Y, Q2Y also skip, you have to skip this transition already there. Now Y is replaced with Y, then it moves left without changing state. Now Q2 Y Y Y. So here again we got Q2 Y only. Same we can apply. Now we can see again we can skip X X. Now it moves left over X. Now Q2 X. Then Y is replaced with Y. Then moves left. Now we are at Q2 X. Actually, for Q2 X, what is the transition? Whenever X is found, so it is going to Q0 state. Then X is replaced with X. It moves right. Now we can see what will happen by applying this. So now X X. Now Q2X, it is replaced with X, then it moves right by changing state to Q0. Now the remaining symbols are YY. Now you can see you are at the cell Y, the state is Q0, but you can see this is earlier not happens. So actually after skipping X, it has to search for A's, but here A is not found. But instead of A, here we got new symbol, that is Y. That means here no A's are found. Then whenever Y is found, you have to replace Y by Y, and by going to new state, it has to skip all Y's till it gets any B. Further any B is also there. So the mission predicts in future any B is there. So like that it skips all. Now you can see here it goes to new state by skipping Y by Y and moves right. Now X X X. Now Q2Y. So Y is replaced with Y. Then it goes to a new state. Earlier we have three states, Q0, Q1, Q2. Now new state you can take Q3. So Q3. So then Y is replaced with Y. Then it moves right. Then remaining two Y's are there. Here one new transition is exist. So what is the new transition? Q0 on Y equal to, it is going to Q3 state. Y is replaced with Y. Then it moves right. So after moving right, what will happen? You can see after skipping all Y's, you can find any B is there or not. So now you are at Q3Y. Now you can see you can skip that Y also. Now Y by Y, then it moves right without changing state. Just to simply we are skipping. Now this is a new transition again. Delta of Q3 on Y equal to, we are going to same state. Just skipping Y by Y moves right. Why you are skipping? To search for any B's are there. Now you can see after skipping next Y also what will happen? Now the configuration will be, now here Y by Y, it moves right Q3. See after skipping over Y, it moves right. Here no tape symbols are there. That means by default blank. Why? Because all the input symbols are prefixed followed by blank symbol. So left hand side all tape symbols are stored. Right hand side it extends by using blank symbol. Now you can see, now you are at state Q3, the tape symbol is blank here. So now after skipping all A's, here we got blank means here no B is found. That means further no B is also there. Now whenever a blank is found here, then what the mission will do? Simply blank is replaced with blank, then it moves right. It moves right, then halts. So after moving right further also here we have blank is there. So now here Q4 belongs to F. Here, what is the new transition? You can write down. So delta of Q3 on blank equal to, it is going to final state Q4, blank is replaced by blanks, then it moves right. Now you can see here the Turing mission halts at state Q4, means finally it satisfies with number of A's followed by number of B's. So then the Turing mission halts here. So this is the final configuration. So here what we assumed in the initial step, here you can see the final configuration. What is the final configuration? Here we consider 3 A's, 3 B's. Then corresponding 3 A's are replaced with 3 X's. Then 3 B's replaced with 3 Y's. Then finally blank. So here we got this final configuration. Therefore, the mission leaves by satisfying 3 A's followed by 3 B's. Then halts at that state. So here Q4 is the final state now. So like that we have to design Turing mission. But long ways to long ways, this logic is changed. But replacement symbol you can take if 2 inputs are there, 2 replacement symbols you can take. If 3 inputs are there, you can take 3 replacement symbols like that. Now you can see total how many transactions we obtained. The final Turing mission now you can write down. This is 1, 2, all are unique. 3, 4, 5, then 6, 7, then 8, 9, 10. Total 10 transitions are there. Now therefore the final Turing mission you can write down here. Therefore the final Turing mission M equal to, write down all tuples Q, sigma, tau, delta, Q naught, blank, F. Now write down all tuples here where Q equal to, what are the states we considered? Q naught to Q4, Q naught, Q1, Q2, Q3, Q4. Then what is sigma? The given string is combination of ABs. Sigma equal to A comma B. Then tau equal to sigma union blank. Then tau equal to A comma B comma blank. Then Q naught is initial state. Q naught is initial or start state. Then blank is B belongs to tau, is a blank symbol. Then F equal to, here what we assume finally, F equal to Q4 is final or accepting state. Final or accepting state. And delta is given below. And delta is given below. Now write down all the 10 transitions. What are we obtained? The first transition is delta of Q naught on A equal to Q1 X comma R. The second transition delta of Q1 on A equal to Q1 A R. Then what is the third transition? So the third one is delta of Q1 on B equal to Q2 Y L. So the third one is delta of Q1B equal to Q2 YL. So the next transition is, so delta of Q2A equal to Q2AL. Next one is delta of Q2X equal to Q0 X or. Then sixth transition, then at Q1, again if you will get Y, Q1 Y equal to Q1 Y or. Then the second B is replaced, then you are coming back, you are at Q2. So delta of Q2 on Y, this is again new. So Q2 Y by Y left. So here also whenever, yes, moving right only. So whenever y is there, whenever coming back, y is skipped and moves left. So now again you will get same Q naught combination. Then what are the new transitions? Now at Q naught, whenever you will see y, it goes to Q3, y by y, then it moves right. Then at Q3 state also, again one more a or more years, you can skip. Then same Q3 y by y moves right. Then the last transition, whenever it says blank at Q3 blank, it goes to final state Q4. Blank is replaced with blank, then it moves right. Now see, these are all the 10 transitions. Now draw its transition diagram and transition table. Transition diagram and transition table. So here 5 states we have: Q0, Q1, Q2, Q3, Q4. All transitions you can write down. So first Q0 on A by X comma R. Then Q1 A by A moves right. Then Q1 on B by Y left. Then at Q2, whenever we will find A by A moves left, then Y by Y moves left. So then whenever it says X, so that is X by X moves right. Then whenever it is coming back in a new transition you can add. So then at Q2 Y by Y moves left, A by L. Then here also further you will get Y also at Q1, Y by Y moves right. Then finally Q0 on Y, Y by Y moves right. Then loop at Q3, Y by Y moves right. Then whenever it is blank, blank by blank moves right. Then Q4 is the final state. Check out all 10 transitions are included or not. Now here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all 10 are included. So this is the transition diagram.